Yeah, so participants have rejoined, I think. Yeah, I welcome all the participants for the second session of day 3. Let me introduce the distinguished academician, and currently he is heading the Department of Computer Science and Engineering with the Internet of Things specialization at Ramachandra College of Engineering, Eluru. He is Mr. Narendra Bavisetti. He is a regular speaker for various FDPs previously. He published so many research papers in reputed Scopus SCI journals, textbooks. He authored textbooks in Internet of Things, machine learning applications, artificial intelligence. And he is a researcher. And so far, he got funding for 3.5 lakhs in AICT ATAL FDP program, MSME, and at the same time, under his guidance, students got 30 lakhs of funding from MSME. Under his guidance, a team is selected for ISF Junicon 100K Global Finals in Dubai and leading another team for FrisGen Ideation Challenge at VTAP University. And he have guided the students to participate in Smart India Hackathon successfully and led them to the national finals. So he's an enthusiast in guiding the students to various government events conducting by the central government as well as state government so far. So we are very much aware. So nowadays, AI is being used in every field. So irrespective of the fields, like for security, like in cybersecurity or any other IoT or any field. So that's why this session is going to give insights for AI, how to use AI for intrusion detection and anomaly detection. So with uh, the kind acceptance of Narendra Bavisetti, sir, for delivering the session. Sir, we welcome you, sir, for the session today. So hope all the participants will have the better insights for this particular session. So please, take over the session, sir. Thank you.
Thank you, sir. Thank you, Indranil, sir. At the same time, Praveen, sir, and St. John's Engineering College for giving this opportunity. First of all, am I audible to all of you? Hello.
Yes, sir. If you're audible, but if possible, you can better the volume from your end, mic nearby mic, etc.
Yeah, now it is clear, sir. I think so.
Yes, sir. Yeah, it's clear. You can
Yeah.
proceed.
Yeah. Thank you. Thank you very much, sir. First of all, a good evening, one and all. So this is Narendra Bavisetti. I'm a head of the Department of CSIoT in Ramachandra College of Engineering. Already, Indranil sir introduced me. Thank you for that. And first of all, today I will be presenting a new and advanced topic, that is AI for intrusion detection and anomaly detection. So basically, an emerging area, it is an emerging area where artificial intelligence, especially in artificial intelligence, we focused on the deep learning. We're already well known. This deep learning and an artificial intelligence is revolutionizing the way we identified and respond to the cyber threats. So in this session, we will definitely focus on that. At the same time, we will discuss how deep learning improving a forensic log, like a log analysis. Basically, we're already setting up for different types of cyber attacks, and the cyber threats also attacks from different areas, like mobiles or a laptop or a different area. Cyber attacks will continuously threatening uh, humans. Basically, how it detects attacks automatically. At the same time, how it overcomes the limitation of a traditional system. By the end of this particular session, you will definitely see how AI based security is shaping the future of intelligence. At the same time, adapt to defense mechanisms. So listen, this particular AI for intrusion detection is basically a concentration on the log analysis. At the same time, how deep learning improves the forensic, and at the same time, how it detect attacks automatically. I said it attacks automatically. How will detects that things. So we will learn one by one. Within the next 1 hour, please cautious and listen carefully in every aspect. A request for all the faculties, or professors and associate professor, assistant professor, PhD scholars, whatever it may be that, definitely it will useful for you in your research gaps also. You will definitely find out the research gaps, and you will definitely write a new research paper along with the case studies also, including some case studies in this particular intrusion detection, right? So let's move on the main slide. It is highlights of the one of the most important transition in modern cybersecurity. So actually, this is a shift from a tradition versus a AI-powered intrusion detection. Actually, it's a signature-based ideas. So this is particular area we will discuss like an evaluation of intrusion detection from the basic at the starting early days, how it will evaluate. At the same time, in early days of a cybersecurity and introduction, if you see here, it's the 2000s at the starting of an area, the cybersecurity intrusion detection relied heavily on a signature-based systems. Like these type of systems works in major like antivirus software. They can scan incoming network traffic, or also system logs. At the same time, for known patterns that matched a predefined list of attack signatures. If I know that we will already face that the malware network exploited at a specific byte pattern or a common structure. Basically, at this time, we will face a lot of problems like a fatal weakness. And we're already well known about the new things, like attackers slightly modified the code. At the same time, they are used a completely new exploit. And basically, that particular things, the system wouldn't recognize it. This is what we call a zero-day vulnerabilities. Actually, previously, these are the threats like a network grew larger, at the same time attacks bases are a more complex. Like traditional areas also collapsing under the basic things like own limitations. Even though there is a paved way of artificial intelligence and the deep learning to completely redefine the intrusion detection. Even though, even though in the traditional ideas, we have a basic strengths and the basic limitations are also available. Let's look at the particular things. Let's look at more closely about the traditional approach. And also, then only we learn about the major drawbacks. Why? Because the problem statement is the main thing. If you know the problem statement, if you understand that particular problem statement, then only you can identify the solution. Then only you can develop any uh, project or a research work. Basically, this is a major problem. We have to find out the problem statement. We have to find out that a particular research gap. So actually, the traditional ideas operates by comparing the network traffics with a database of known malicious signatures. If you know about this, like matching fingerprints, um, but precious, but only works if the fingerprints already exist in your records. These are basic things. At the same time, static patterns also. Static pattern means, for example, once a pattern or a rule is defined, it does not change unless a human expert updates it. This is a basic static patterns, basic definition. At the same time, there is a limited effectiveness against of novel threats. We're already well known as the cyber attackers innovate traditional systems, fall behind. It's like will simply can't detect unknown attack types, like a dynamically or choosefully. Different types of struggles are facing in a traditional ideas also. Basically, in the traditional also, we have a major problem is high computational complexity. For example, if the volume of data increases, especially we'll think about the enterprises networks. If you know about the enterprises networks, they're scanning every packet against of a massive signature database. Becomes extremely resource intensive. At the same time, course of a dimensionality. So if you ask me, sir, what is the cause of dimensionality? This is a new word, I think. So no, this is not a new word. Actually, if you think like it's a modern network traffic generates. There's a thousand of futures like IPs, ports, like a flags, payloads, like if you know about the metadata, stamps, timestamps. These are all such as a high dimensional data we have available, and even though they are sensitivity to irrelevant future, and also it can easily produce a false alarms. Even will listen for direct different types of false alarms are also aspects also attacks me attacks our sorry. So behalf of that, so we face lot of limitations like a signature based detection and the static patterns, at the same time limited effectiveness or high computational or dimensionality. So the basics, these are the threats we have to face in the traditional ideas. Behalf of that, we will go to the AI powered intrusion detection. Then came the revolution, that is an AI powered ideas. In this AI powered ideas, there is a learn patterns directly from data. This changes everything. I think this is changing everything. Let's break down one by one, like how AI and deep learning completely transformed intrusion detection. So actually, in a deep learning or an AI, we're already well known about the adaptive learning, at the same time detection of novel and zero day attacks and future learning. At the same time, handled complex, at the same time high dimensional data, along with continuous adoption. These are the basic things we have to work on in every aspect. Let us go with one by one. For example, in AI powered AI ideas, there is an adaptive learning. For example, in this particular adaptive learning, you have to fix the rules and you have to continuously learn from the new network traffic. At the same time, there is a detection of novel and the zero day attacks also. It is the models identify static anomalies. So even though if you go with the detection of a novel and zero attacks, definitely if an attack has never been seen before, the system can still flag it as a suspicious range. At the same time, we have another basic thing in AI powered areas that is nothing but a future learning. So we're already well known about the traditional ideas. That system is completely dependent upon the human experts. But the deep learning automates this process. That's the main advantage. Like we're already well known about the neural network. And that particular neural networks is extract the relevant features directly from the raw data, like a packets or sequences, like traffic volumes or connection timings. They're saving the enormous time. At the same time, improving the precision. Even though we have some models like CNN, like and RNN, it will be the easily process hundreds or thousands of input variables, find a non-linear relationships. At the same time, it detects the patterns invisible to the human analytics. Just learn about the traditional and AI powered. What we face the problems in traditional ideas and how it detects and how they give a solution to the AI powered ideas. So I will give you a clean differences between the traditionals and the AI powered ideas also. If you go to the traditional, it is like a signature at the same time or like a rule based. If you go with the AI powered ideas, the data driven pattern recognition, this is the most advantageous. At the same time, even attack detection also, the traditional ideas is fails, but AI powered is effective against the novel threats. Same, if you go with the future engineering, the traditional ideas, it's a manual, human dependent, so completely depend upon the manual base. But it is the AI powered ideas, it is automated future learning. That's the main advantage of the AI powered. Even if you go to the adaptability or a scalability or a maintenance, so all of them, AI powered is a dynamic, at the same time self learning, and it's a continuous self improvement. That's the main advantage of the AI powered ideas. And even though if you go to the real world illustration, for example, um, I give an example. Um, Consider a data center. Like there is a data center handling of millions of transactions per minute. A small example, for example, if you take this, a traditional IDS would require constant manual updates to detect each new attack type. If a hacker slightly modify an existing ransomware payload, the signature won't match and the system remains silent. Now imagine at the same time, an AI-powered ADS, it's trained and also historical network traffic using. We are using a deep learning models such as autoencoders or LSTMS. These models can understand the normal rhythm of transaction, the average number of number or a size at the frequency. They're already well known. Behalf of that, the ransomware starts incubating the generating abnormally with the input and output operations also. That's the power of a behavior learning over signature matching. And if we go to the final things like traditional ideas, it's a reflective, rigid, and limited attacks. But AI powered, not like that. It will be definitely given adaptive, intelligent, and effective even against unknown threats. That's what I said. Like it's a cyber attack also. Even if you go to the cyber attack also, we will handling on each and everything. Now that We understand how AI-powered systems differ from the traditional ones. Let's look at why deep learning in particular has become the backbone of modern instruction, like these type of intrusion detection and anomaly detection. So I will explain one by one. Like here, I consider for basic things like a CNN. You're already well known. There is a convolutional neural network, and at RNN, there is a recurrent neural networks, and at the same time, LSTM is also there. We know long short-term memory. We have the auto encoder and the transformer and the GNN. The first basic big advantage of these automation is traditional intrusion detection depending on the human experts. It's deciding what part of the data mattered, IP address, packet size, timing intervals, and so on, a lot of things. This process was a slow, error prone, and it is failed whenever attacks changes the tactics. But this deep learning eliminates that manual work at the same time neural networks, and it will be the automatically learn the patterns from a raw traffic or a log data. When you go to the CNN, for example, the discovery of a spatial relationship in packets, the RNN recognizes the sequence of events over time. Even the model itself figures out the what matter most. Even no human intervention is required. That's what I said. This type of ability to learn directly from the data makes detection faster. At the same time, it is smarter also and less dependent. And even we already defined the rules, like a predefined rules. So if you ask like high detection accuracy, what is the higher detection accuracy? The main advantage is accuracy. We'll see that the cyber attacks rarely look identically. There is a small variations like a centric static systems, and the DL models also, however, excel at recognition subtotals like non-linear relationships hiding in a massive data. We will face a lot of things, even though, but if we face in that by training on a millions of examples of both normal or malicious behavior also. These models form an internal understanding what normal looks like. So basically, these particular things are available in the studies also. Consequently, like a show deep network or for classical, like a machine learning algorithms such as SVMs, decision trees, detection predictions, and recall, it will be the handling of a noisy and balanced data move. And the next advantage of these particular things is adaptability. This means that when attackers change the behavior, like I say, switching ports, payloads, or traffic differently, then the AI system can relearn those variations without human reprogramming. Even though there is one of the impact that is nothing but a synergistic impact, that is nothing but it is a combine of different types of advantages. That's why now the industry is also rapidly moving from the signature based intrusion detection towards the deep learning based models like a frameworks. Even though the goal is not just to recognize the past attacks, but to predict and prevent future ones. There is a main advantage. That's why, even though, normally, so many of our enterprises, like a Flipkart or Amazon, or some of different types of apps we are using nowadays. Nowadays, we are using different types of websites also. So basically, these types of websites also attack like a cyber attacks. Definitely, they will face. That's why these type of industries are completely rapidly moving the signature-based intrusion detection. So, will you see that? That's why we introduced the deep learning models for intrusion detection. So I revealed one last string, that is a CNN, at the same time RNN, and that's why you're using LSTM. Well known about the CNN, that is nothing but an application based. If you see here, it is a packet header analysis. At the same time, it will the future extraction for classifications. If you go to the RNN, it will definitely go with the flow analysis, and also it will accommodate the temporal pattern recognition. And we're already well known about the LSTM. That is the attack prediction, and that is the application of anomaly detection. And autoencoder, that is nothing but for traffic compression and the same time data denoising. This type of things we are using. And if you go with the transformer, it will be the like a log message classifications, it anomaly detection we're using. And for example, if you go to the GNN, there is a graph neural networks analysis. It will the attack path risk construction and multi-hop attack detection. Next, we'll go to the next slide. That is nothing but deep learning in a forensic log analysis. Basically, this deep learning in a forensic analysis, log analysis, is nothing but why forensic log analysis matters. At the same time, why the pre-processing making a data understandable. At the same time, sequential analysis with LSTMs, and why the consequent understanding with the transformers, and also attack path reconstruction with the graph approaches. With the basically, finally, I will tell you that the particular thing, why deep learning changes the game, the entire game, that will explain in a one by one. For example, if you see here, there is a transforming a raw log data into an actionable security insights like raw logs. It will be go to the pre-processing, and then it will be the sequential analysis. And the next, it will go to the contextual understanding with an attack graphs. So basically, why forensic log analysis matters? First of all, we will definitely know about this particular thing. Why forensic log analysis? Whenever a cyber attack occurs, whether it's a malware or unauthorized access or a data theft or different types of a log contains, mainly the log contains is as timestamps, IP addresses, or login attempts, or file access trials, error events. There is a lot of traditional analysis method using keywords such as but the deep learning offers a smarter, scalable way to detect hidden attacks patterns. That is a rule-based system. It will they can't see those. That's why. Even the log pre-processing. The first step in the forensic log analysis is a log pre-processing. It will be the raw logs come in the multiple formats like system logs, application logs, and cloud service logs. There is a lot of pre-processing, each with a different structure. Definitely, the logs are in a different structure based. To train a deep learning model, these logs must be converted to the structured format, like JSON or CSV. Definitely, these logs must be converted to the structured format. Why? Because it's unstructured. There are different types of structures are there now. like a system logs or application logs, right? So that's why we will pre-processing that particular things. Then only we apply the tokenization and normalization. So if you ask me, the tokenization breaks the log lines into the components like IP and a time, for example, IP or a time or message type. Same normalization also same there. The normalization standards like it's converting the all stamps, all timestamps to a common format or masking IPs. That's why we are converting the raw logs into the pre-processing. First step and first and basic and important thing. The simple example, it is making the data understandable. The log processing is nothing but it is a structured format conversion. Definitely, we will get the different types of structures. That's why we are using this type of structured format conversations. And then it will be the sequential analysis. The SQL analysis is nothing but LSTMs. Just now we learned about the LSTMs. It is network to analyze the sequence of log events. That LSTMs are designed to capture long-term dependencies also, meaning they understand how earlier events influence later ones. In cybersecurity, there's a many attacks follow a specific order, like a scanning, explosion, privilege, or explanation, data explorations. LSTMs can only model these temporary patterns can identified when a sequence of a normal looking events. For example, a failed login followed by privilege escalations, then it will be the data access event might be seen harmless individually, but LSTM models learn how to recognize these as a threat chain. This is a simple example. Even though there is a privilege escalations, even though there is an data access, the LSTM models can learn to recognize the different types of threatening chains. And then we go to the contextual understanding. Contextual understanding basically concentration of two things. One is a self-attention, and the another one is reduces false positives. Actually, while LSTMs handle the sequences in the before step, while LSTMs are handling the sequences, they sometimes struggle with the contents like context spread over long distances. That's where we are using a transform models come in. In the previous session also I involved the transformers. That's why the transformer models come in. Transformer uses a self-attention mechanism to determine which parts of the log sequences are most relevant to the current event. Imagine analyzing for 10,000 log lines, a transformer can instantly focus on the 5 or 10 entries that actually related to the suspicious action. Definitely, these types of ability dramatically reduce the false positives also, allowing analytics to focus on only a genuine threats. And then finally, we go to the attack path construction. Once an anomalies are detected, the next step is attack path reconstruction. It is figure out how the attack is unfolded. That's why even though in the previous slide I introduced the graph neural networks, here it works. Here it works. The graph-based modeling is used. Each log event becomes a node and relationships like accessed, modified, or executed form the edges, right? If you know about the GNN are like related algorithms can then trace how the attacker moved laterally through the system. Actually, this approach has achieved impressive results. I followed for three essay papers or Scopus papers. I learned about that. A graph-based models reach a 92% FN score and reduce investigation effort maybe for 50% nearly. That means faster, at the same time more accurate forensic analysis. Before that, there is a problem. If anyone concentrate on the research gap on cyber security background, definitely go with the graph based models. Like it will be the reached on a different types of offense codes, graph neural networks. And finally, I said why deep learning changes the game. Traditional forensic methods were reactive; they relied on humans to dig through logs after a breach. But the deep learning makes a process productive and it is completely continuous monitor logs in a real time, even though it will detect the and every anomalous, like even predict the suspicious behavior or before damage occurs. Even I will give you one simple example, one real life example. There is a real time example. I think the cyber attack in 2022. Yeah, there is a 2022. I think so. There is a major European cloud provider. It suffered a data breach where attacks use the stolen employee credentials, like a sensitive data over several days. We go to the traditional rule-based monitoring system, completely missed the attack because missed the attacks because all actions appear normally. Valid logins, there is approved devices, and small file transfers within daily limits. Even though after the breach, the companies implemented a deep learning based a forensic log analysis system using LSTM and the transformer models. That LSTM analyzes the millions of log entries and learn each employee normal login patterns at the same time access behaviors also. That's why the transformer added the contextual addressing. At the same time, understanding also. That's why the focusing on unusual sequences. Within hours, after the implementation of unusual sequence hiding among the normal activities, within hours, the system detected a suspicious pattern, repeated API calls. At the time, I think so, some around 4 a.m., like a 3 a.m., accessing files across multiple storage servers. So each action looks like a legitimate. The combined sequence was highly abnormal. Even though the AI flagged it is also 98% anomalous score. After the investigations, also the later it's confirmed the attack set data exploration routines analysis, which one is that took weeks, was completed in hours, showing how deep learning turns a log data into the real-time intelligent forensic insight. Before it will take a weeks or a month's time, but then it will be the hours or minutes. So that's why we learned about the basic things of deep learnings and in the cyber attacks also, why the deep learning are involved and how the data includes that thing. So we'll go to the main today. There's a research gap in the case study. So now let's discuss about the deep learning is being in cloud and edge computing. Actually, in this slide, I want to focus on a few points. The first one is how it is challenges these type of cloud attacks or cloud and edge computings of a case study. The challenges in cloud and edge security. This is the first point I want to discuss about today. At the same time, deep learning solutions also in the cloud. I add few research papers and others also. At the same time, how the deep learning for edge devices and the real world impact. So we'll discuss one by one. Basically, in a cloud environment, there is a multiple users share the same infrastructure. Like a network traffic constant scales up down. And for example, if you lot of times there is a big billion day or Amazon sale, lot of the time of 12 o'clock, all the users are wake up. One second. Sorry for interrupt. At the time of big billion day Amazon festival sales, all the users are completely waiting at that time, like at 12 o'clock, while the sale is live, or sale is live or not. Definitely we will wait, right? At the same time, at Tatkal time, IRCTC Tatkal time, 10 a.m. we will definitely book on the seats like AC, or 11 a.m. we will definitely book our tickets of non-AC tickets. At that time, the servers is so busy. The network traffic is constantly scales up and down. Even that particular type of a conventional institution detections also system can't handle the dynamic behaviors. Even they generate too many false alarms or missable threats. At the time, the challenge is even tougher. Even the devices have a limited processing. That's why if you see here, recently IRCTC also involved introducing the new thing who are other updated, other something other card updated in the particular IRCTC website and app, then only you book the Tatkal tickets. So it will definitely release some traffic. At the same time, third parties also. There is a third party bookings are also happen. So that's why they definitely fall took a they definitely generate the too many false alarms. At the edge also, the challenge is even tougher. Even though the device have limited processing or a power or a memory or a bandwidth, even the running complex security is also main. This is where the deep learning comes into play, enabling a lightweight at intelligent detection systems. Even though these are also one of the ideas, these are also one of the basic ideas. Who said that the Flipkart or Amazon sales are live at 12 a.m.? At the time, the servers are very slow, but the users are accessed at that time only. It will be the easy to access of all the things. Easy to book. But even though at the time also nowadays we will face a lot of struggles. So I will go to the one by one case study. For example, if you go to the DDoS detection, here I got the three things. So here the first I will go to the DDoS detection. Basically, this DDoS detection is nothing but it's a one major study. It is uses of federated learning for intrusion detection across multiple cloud tenants. Instead of sending raw data to a central server, each local node trained a small neural network on its own data. I repeat, this is a basic, even though this is a new one of the DDoS detection. 2022, there is a Q1 paper is there, and if it is available in the Scopes the database also, they are mentioned that is a federated learning for intrusion detection across a multiple cloud tenants. Instead of sending a raw data to a central server, each local node trained a small neural network on its own data. Then only the learned parameters were shared the aggregated in the global model. Even these type of approaches preserved data previously while improving accuracy across the distributed systems. That's why the system achieves the even you never believe even the 94 detection accuracy while cutting a communication cost by half. Even in the first paper, there is a federated learning for a multi-tenant IoT. In that particular things, they mention instead of sending a raw data of a central server, each local node train the small neural network on its own data. They change it for small change. Even another work also, the same thing, DDoS detection attacks. They are using by LSTM. There is nothing but by directional long short term. It will be the basic model for a detection of DDoS attacks, even though they are involved in a IoT powered cloud environments. The cyber attacks, but the cloud based on the IoT. Their model could recognize complex temporal attacks sequences in real time. They working on the real time, even the system to block malicious traffic before it spread. That's a major advantage of particular things. Right. Same, if you go to the edge of research focused on the designing lightweight or deep learning models optimized, there's for example, there is a one paper I focused on, this one, DNN with PSO for CSC. It is a combined of a deep neural network with a particle spam optimization algorithm. Actually, it is an electrical neural network based. It's a neural network based particle spam optimization, the group form algorithm to fine tune parameters efficiently. They used the simple, they used the data set. There is a CSC IDS 2018. There is a data set. Even that data set is available in the GitHub also now. You could just enter the code like a GitHub code that's a CSC IDS 2018. The data set's available. And they achieved remarkable accuracy without overloading the device's CPU. Similarly, another one also. This one proposed an autoencoder based system that could be learn a normal traffic patterns using a very small amount of traffic data, like ideal for edge devices with a low storage. Then there is a one other thing. There is a Lee et al. There is an autoencoder and SVM for lightweight devices. This particular thing, it is developed a hybrid model combining an autoencoder and SVM, creating a lightweight instruction. At the same time, this intrusion detector for IoT nodes that could run on microcontrollers. When you see nowadays, a lot of the people working on the multidisciplinaries. So it's a better to work on the multidisciplinary. Why? Because why the power systems or why the power electronics or why the IoT sensors are including in this particular cybersecurity, why they are including, and these are is it any need. Even though nowadays we're already well known about the different types of sensors. Nowadays we're already well known about the different types of attacks. Even now we're already well known about the different types of AI. Even though up to now we are using different types of AIs like a ChatGPT or a Gemini or a Prospect AI or different types of AI you was using. But even though it will generate for new developments by combining of two things, even though different problem statements comes from different adding of different multidisciplinaries. When you stuck on the one particular area, it will never ends. It will stuck there only. We'd already learned of so many working operations. Again, there is another new research work. There is a quantum computing and quantum cryptography. If you write a paper on a quantum computing or a quantum cryptography, it will some of publishing somewhat is when comparing with the previous work. Why? Because the quantum is updation now. That type of a case studies we will learn about that. Even here also the case studies of a main key takeaways is that deep learning adapts to dynamic cloud environments. That is, a deep learning adapts effectively to high dynamic cloud environments. Even the federated learning enables it will the cooperative intrusion detection while protecting user privacy. At the same time, the resource efficient models also that ensure that even a low power edge devices it will can participate in a global security network also. Even if you go to the I would like say I'm enthusiastic to explain in the real world example. To give you a real life example, in 2023, I think it's a smart factory in Japan used a federated deep learning ideas to detect abnormal behavior among its edge devices, controlling robotic arms. Instead of analyzing data centrally, each device learned locally and contributed to shared a model. This is a better to use of a federated deep learning. Even in Japan, some of the smart factories they are using a federated deep learning ideas. In the previously, I said one a real of example. There is in a 2022, there is a major European cloud provider, right? The same thing here also. Even in the 2023, there is a smart factory in Japan also. Even now, they are using a federated deep learning ideas. Why they are using? There is a one reason to detect the abnormal behavior among its each devices. At the same time, it's controlling the robotic arms. So that's why we are focusing on this particular cloud and edge computings. When you're focusing on these particular things, it will be the useful, it will be the effect on different types of environments. And the next, we'll go to the case study of an Internet of Things security, will based on the cyber, right? So here the security IoT environment presents with a unique challenge due to suffer resources like one of the most challenging. There is a um, different types of key challenges are why the key challenges in IoT security and the why traditionally approaches fails, and also I included the deep learning based solutions, and also I said one real time example behalf of this particular thing. The basically the first big challenge is resource constraints. Most IoT devices have a small processors and low memory, which makes it nearly impossible to run heavy encryption or intrusion detection algorithm. This is the first one. The second one, there is a defined device like the name is heterogeneity. So thousands of different vendors, protocols, and hardware types are also available, existing. It's a coexisting also in one network. Even these lack of standardization makes it also difficult to build one size fits, even in all even in the all protection. Finally, we will face the same problem like a security vulnerabilities. At the same time, like a weak authentication, unpatched firmware, and also definitely we will face an unsecured communications. These types of problems we will definitely face. That's why these devices are exposed to attacks such as botnets, data leaks, and remote hijacking. That's why I said the white traditional approaches fails. The traditional intrusion detection system simply can't handle the scale or the diversity of IoT ecosystems. The IoT ecosystems, they definitely unhandle. They can't. Even though if they handle, they will definitely require the frequent manual updates. And also they will definitely know the consumer for more computational power. Even though, moreover, they're ineffective and detecting a new or involving the attack patterns also, which are common in IoT environment. This is why the deep learning has become the preferred choice. It learns it directly from the network data, detects anomaly set automatically, and can even adapt as the device behavior changes. I Here I discussed that there is a raw log. The raw log processing, right? Here we face the one major problem statements are there. That problem statements will solve here. Sorry, yeah, we will handle on these particular things. If anyone work on that, the researchers, if you want to work on deep learning models, trailer for IoT, or the deep learning models, but if you want to use any particular things, sir, for example, sir, I well known about the IoT. For example, I know well about the cybersecurity. I know well about the data science. So you just focus on that particular thing, but related to the another one. Like for example, if you go to this particular key paper, it is in a 2021, I think. String it a string. They are used for analyzing time series. At the same time, IoT traffic capturing and sequential attack behavior, such as the pod scans and a brute force logins. These type of work are this is the last I think so paper one is working on this particular area, that is which is analyzing the time series IoT traffic, which is the capturing of a sequential attack behavior, such as the pod scans and the brute force logins, like that. At the same time, there is a CNN, there is a CAN. In this particular convolutional neural networks with the APSO optimization, it helps to detect spatial traffic anomalies essentially. If you hear in LSTM, they are focusing on the time series. In CAN, they are using convolution models that help to detect the spatial traffic anomaly efficiently. And if you go to the autoencoder, it's just one single step. They're applied for unsupervised anomaly detection. They learn normal patterns and flag any unusual behavior. Sir, I faced a lot of problems in these particular areas. So how can I write the research paper or case study? We'll go to the Ensemble CNN. It will combine the multiple models. It's explainability tools to make ideas decisions more transparent also. The innovations of a key innovations also these particular things. There are the resource aware model designs with efficient training algorithms and the layered secured architecture and with a detection mechanism. These types of a case studies are available. We work on that, go on these particular things. If I said, I want to set real world an example again. So why? Because if you, even the students also listen the class while teach a real time an example that will easy to understand. So that's why I include a real time example in every slide. Why? Because it's already 8:30. So many of the faculties they are in a family with family. But this type of research work is definitely useful in your profession. So that's why I said there is a real world example to understand the practical use. Let's consider a real incident, that is Mirai botnet attack. In anyone known about it, Mirai botnet attack in 2016. There is a Mirai malware infected thousands of IoT devices like cameras, routers, and the DVRs, and they are turned them into a massive botnet used for distributed denial of services. That is a DDoS attacks. Just now I said here DDoS detection. That is a DDoS attacks. But the traditional ADS completely failed to detect it because each infect device generated only a small amount of suspicious traffic individually. So that's why the researchers later applied the deep learning models using LSTM and autoencoders on IoT network logs. These type of models learn the normal communication behavior of devices and flagged small but abnormal traffic spikes and repeated connections attempts as early warning signs of infection. Using these types of methods, several cloud service providers were able to detect the Mirai-like behavior within a minute, reducing a downtime and preventing a large-scale network consecutions. This is one of the basic an example. Okay, and finally, these type of case studies like deep learning models and the lightweight architecture are most important working on in the research gaps, working operations. Next, we'll go to the critical research gap. I will include two slides only and given a clear explanation. So that's why all of you please working on that if you are interested really. One second, sorry. Sorry, one second. So I started with a critical research gap. So basically, these critical research gaps, even though in a deep learning based intrusion, the first major gap is business adaptability. Most AI models are designed in isolation. They don't consider the real operational context of an organization. They will fail to align them with the business policies like a network topologies or complaint standards. Similarly, these systems lack environment awareness. At the same time, the second challenge is of a trusted worthiness. And the third one is operationalization. So the first one is the first major gap is a business adaptability. And the second one is worthiness. And the next we will go to the operationalization. So I will explain in clear one basic example. It will easy to understand this particular critical research gap. I think in 2023, a large private bank deployed an AI-based intrusion detection system to secure its data center. Initially, actually, the system performed extremely well, but it's detecting the malware, like phishing attempts and network anomalies, automatically with a high accuracy. But however, a few months later, the bank upgraded its infrastructure, like adding new servers, applications, and the network segments. Then soon the model's performance began to decline. But it couldn't recognize some new data patterns and started misclassifying the traffic. This is now the concept drift problem. This is a basic concept drift problem. As a result, The ideas began the missing real attacks while flagging a normal traffic or a cybersecurity based or a lack of explainability. It will be couldn't understand why the AI markers certain events of as a malicious, which makes it hard to trust and act on its alerts. This is a real case shows that while deep learning models work brilliantly in controlled lab setups, they often struggle in dynamic in the real world environments. It will clear highlights the need of adaptive, explainable, continuously updates the AI system in cybersecurity. That's why we'll go to the basic business adaptability. That's why we go to the trustworthiness. That's why we operationalizations of basic needs. When you go to the basic innovativity, they fail to align the business policies, network topologies, or compliance standards. Similarly, these systems like a lack of environmental awareness also. Even though the meaning they can't automatically they adjust to new infrastructure or technologies. Even though if you go to the second challenge, that is the trustworthiness, the lack of explainability limit trust and makes it difficult to validate system decisions. Finally, operation remains a huge barrier. In operationalization, it is a deploying these models at a scale, like a monitoring performances or a black box, challenging the monitoring and scalability, which will the continuous improvement need for methods that adapt to environmental challenges. That's where the real world ideas must update themselves dynamically, handling like traffic or provide actionable alerts like that. You go to the key insight of this particular thing, it addressing these gaps is crucial for realizing the potential of AI driven cybersecurity. While discussing the case study of before slide in the Internet of Things security, we face them by traditional approaches fails like a high computational requirements and it difficult in model deployment. Then only we'll go to the lightweight idea solutions like LSTM, RNN. That research gaps will fill this particular business trustworthiness and operationals. Even though in 2022 there is a multinational e-commerce company, even they are implementing a deep learning based intrusion detection systems to secure its cloud infrastructure. During the initial testing phase, the system worked perfectly, but it detects phishing attempts, unauthorized logins, and abnormal API requests with nearly 96% accuracy. However, basically, after a few months, the company upgraded its payment gateway and added a new microservices. Suddenly, the idea started falling. It began the flagging normal payment requests as suspicious and missing genuine threats. It happened because the AI model was trained only on the old data and it could not adopt the new network behavior. This is the classic case of concept drift, where the model's understanding becomes outdated as the system evolves. Moreover, when the cybersecurity team tried to investigate why the ideas flagging legitimate traffic, they found to no clear explanation. They also the system acted like a black box. That's why they are involved. The analytic had to manually analyze the thousands of logs to understand the reason behind the alerts. Actually, this incident clearly explored two major research gaps, like a lack of credibility and the lack of explainability in the deep learning in the based intrusion detection systems. Even it proved that AI models need to learn continuously and provide transparent reasoning. Why? Because it to be truly reliable in real world environments. And the last one, there is a future directions and conclusion, finally. And this is the final slide. We will definitely learn up to now the basic future directions. Even though deep learning has achieved a remarkable success in intrusion, anomaly detection, real world implementation, even though still faces the challenges, the business adaptability AI models must go beyond lab accuracy with the real organized environments. That's the main thing. For example, even the ideas also in a hospital will have a very different network behavior compared to one in a financial institutions. Even in the future systems also, they must become the context aware. Actually, it's adopting to new users like a workflow and network changes without a fully trying. But it will integrate the AI with the domain of a specific rules and policy frameworks. It will make the intrusion detection more operation relevant. Even if you go to the trustworthiness also, one of the biggest barrier today is the black box nature of deep learning is a secure analytics often don't trust models. Even they met that make predictions without explanations. This is why explainable AI, XAI, is becoming critical. That's why the models such as a clearly justify why a particular event or a packet was flagged as malicious. And that's why was it with the IP pattern, the payload, anomaly, or the timing behavior. Even now, even now, the researchers exploring the attention visualization with the future attribution techniques. But behalf of that one thing, when you go to the business adaptability or trustworthiness, but basically this integration or AI is basically working on that operational organization also. That is nothing but operational development. This is the third direction is the real world deployment. Most AI IDS models are tested only on benchmark datasets. Very few, maybe very few are actually integrated into the life systems. Like this edge computing or further learning approaches will also help along a multiple devices. And finally, let us go to the one simple small example. Okay, one is a small example. He said it's a real life example. Up to now, I said e-commerce company or companies like that. Let's take a real time example. Real time example from Microsoft Azure Security Center. Actually, Microsoft has deployed a large scale airport intrusion detection framework across it's a global data centers. I think so. The system uses DNN, deep neural networks, even though they are already included autoencoders and graph-based analytics to detect anomalies in real time. Initially, the system faces the same problems as research models like of transparency and frequency false positives. To solve this, Microsoft integrated explainable AI modules that highlight exactly which features triggered the alert. For example, suspicious log time, rare IP behavior, and tenant access. The company has also introduced a continuous retrying pipelines. Like there is a clouds. Right now, we are using the clouds, Azure and AWS, or the Google Cloud platforms. We have up there also. The company are introducing the continuous returning pipelines. As a result, The system reduced false positives by over 40%, and they detected 0 day attacks days before traditional systems did. This is one of the basic and example proves adaptive, explainable, and continuously learning modules are not just a theoretical ideas. They're already reshaping modern cybersecurity. And finally, I would like to conclude that the artificial intelligence, especially the deep learning, is revolutionizing intrusion detection and cybersecurity. It definitely enables a system that don't just react to threats, but learn, adopt, and predict them before they strike. At the same time, it will the future lies in combining AI's intelligence with human side to build transparent with a self-involving security system that will easy to work on it ability. And the future lies in combining AI intelligence with a human insight to build a transparent and trustworthy, I think, a self-involving security systems. So work on that, on this particular, and at the same time, working on every aspects that will be the useful for in everything. And finally, this is conclude my thing. So while impact the thing, one thing I want to tell you that actually we explored the main agenda, that is nothing but AI for intrusion detection. It's a real world implementation and understood how it can impact our lives, our work, and I hope this session has been given your practical insights. I think so sparked even, and I think you have to think critically about applying these ideas in your own contest. I think so. So better to work on that. It will definitely be useful. And thank you, one and all. And if you have any queries, and if you have any queries regarding of AI for intrusion detection and the research gaps and the research works, you may ask. I will give you a clear explanation.
So, Praveen sir, you can unmute the mics of participants.
Mics are already unmuted, sir. Mics are all unmuted. They can talk.
Sir, some of the participants are placing questions in chat, sir.
Yeah, 1 second, sir. I see. Can you suggest an AI model? Yeah, definitely, sir. Um, Actually, we have a preferable open sources also available. Uh, there is a few links are there. I will share in the chat box itself. There is a preferable open sources also available. Like for example, I will tell you 1 second. There is a one public sector, so now working operations are there, like, mm, yeah, I will type. Sir, can I type or can I tell on here only? Actually, there's a few things like machine learning models, like IoT VL code is also available. And one thing, another one is DPeaker. There is a open source, I think so. DPeaker. Or if you go to the another source, that is one of the source. Additional tools also the CodeQL, right? CodeQL. If you CodeQL is one of the open source, and it's by SML. And the second one is WorldPeaker. This is also second one. Or IoT VUL code. This is a third one. These are the most preferable at the same time. It is an open source also. You have to definitely, it's an open source kind model. You will definitely take the IoT vulnerabilities. Definitely. It will work on. If you have, if you want to work on this particular thing, sir, I will give a mail address. You send your problem statement. We will work on that. No issue. It's one of the major open sources. Like, can anyone? Is there anyone, sir?
Yeah, participants, if any questions, you can. Otherwise, we'll conclude the session. Yeah, sir. Yeah, thank you, sir, for your valuable insights regarding AI for intrusion detection and anomaly detection. Uh, I thank all the participants for participating in day 3, and our co-coordinator, Dr. V. Praveen Kumar, and our supporting staff, Sri Vaka Shrikant Garu, sir, and our resource person, Mr. Narendra Bavisetti, sir. So thank you, sir. Thank you for your valuable time and giving insights regarding the today's agenda. Yeah, thank you, sir. So I'm going to end the session. I request all the participants to fill the feedback form and ensure that the name given in the feedback form is also the same as the name what you have registered with your ATAL online portal. It will be making us easy to map the attendance into the ATAL portal. Yeah, phone number, email ID, and name kindly use the as if it was given in your ATAL portal. So such that we can easily map the attendance to the portal. Yeah, thank you, sir. Thank you. I'm going to close the session.